Hi, I'm Richard Fine, Head of APAC Business Development for CleanRobotics. Today I'm going to share with you a revolutionary solution that will forever change the way consumer waste is collected and sorted in the built environment.
Human beings get confused about what's recyclable.
Right now, only about 20% of what goes into your recycling bin winds up actually being recycled.
If you've ever gone to a place that has an array of waste receptacles, you've had the experience of trying to figure out where to put your item of waste. That confusion at the point of disposal causes contamination. We make a system called TrashBot that uses AI, computer vision, and robotics to detect waste as you throw it away.
We take the decision that you have when you're throwing away an item into recycling or landfill, and we automate that.
At CleanRobotics, we think that you really have to sort accurately as early as possible so that the industry can then recover as much value as possible.
Global waste generation continues to grow, with South Asia forecast to almost double the amount of waste in the next 30 years. In order to address this issue, improved waste management and resource recovery is required in every region across the globe. Reduced material contamination, coupled with consumer education, can significantly improve the recovery and recycling rates in every country. In Singapore, the total recycling rate across all materials is currently at 52%, and the government has set a target to increase the national recycling rate to 70% by 2030. Capital Land is committed to achieve a 25% recycling rate in day-to-day operations. However, this comes with challenges. According to a 2018 study by the Singapore Environmental Council, 70% of respondents did not know fully which items were considered recyclable, and 40% of materials placed into recycling bins is contaminated and thus incinerated. At CleanRobotics, we have the technology to address all stakeholder needs and subsequently support government, consumers, and Capital Land sustainability goals relating to the recycling and recovery of resources. TrashBot is a robotic waste bin that automatically identifies and sorts up to 4 customizable material categories. The unit is 3 times more accurate than human beings in identifying recyclables. TrashBot is a resource recovery station with smarts. TrashBot uses sensors, computer vision, and machine learning to detect and classify waste as it's thrown away. The average consumer is only 30% accurate when choosing between recycling and incineration. TrashBot has a sort accuracy of up to 90%. TrashBot provides numerous benefits for facilities managers, including real-time waste audits and the ability to make decisions based on accurate, granular data. It also improves efficiencies of cleaners, as they only need to attend to the units when notified by SMS, and increases the recovery of recyclable material whilst reducing the volume of waste sent for incineration, directly impacting the cost of waste management. Using built-in cellular communications, all collected data is uploaded to the cloud and accessible to all relevant persons via a dashboard that displays all TrashBot locations and related resource and recovery data in real time. This allows facilities managers to analyze and report on waste and recycling targets and provides valuable feedback and insights to all stakeholders. The 43-inch monitor delivers relevant and location-based educational, promotional, or advertising content, updated by an intuitive online content management system. The example illustrated here is an educational message displayed on screen based on data at a specific site location that showed a high level of beverage containers were being disposed of while still containing liquid. Waste reduction is of a growing concern for building owners. One of the principal driving forces behind this is the realization that it is a commercial issue. The less waste that is created, the less you have to pay for its byproduct and waste removal. TrashBot delivers benefits relating to certified building sustainability programs, and the data can be used to measure, track, and communicate waste management and recycling targets. By effectively segregating recyclables from general waste, overall waste management costs can be reduced. Each TrashBot installation increases the recovery of recyclables and reduces the cost of disposable for non-recyclable waste. An example With 3 trash bots installed at Capital Land's Raffles property, a total of 7.5 tons of recyclables could be diverted from incineration. At a scale of 40 units, assuming a 40% diversion, TrashBot technology can divert 100 tons of recyclables a year, abate 500 tons of carbon dioxide, and generate $19,000 of savings annually. This is before accounting for the added value of enhanced education, data analytics, and programmatic changes like potential new organics programs or refined purchasing strategies. Best of all, the data is accurately captured at the point of disposal every time. CleanRobotics, together with Elba and Biopack, will engage with the packaging industry, government, and the recycling industry in Singapore to provide transparent, real-time material recovery data, vital for effectively monitoring and managing the recovery of valuable resources that will ultimately help Singaporean businesses and communities achieve, if not exceed, the targeted 70% recycling rate by 2030. Our technology has been developed and refined over the past 5 years and is now ready for deployment. No other smart bin solution on the market today can compete with TrashBot's advanced data capture, data analytics, material sorting accuracy, and educational capabilities. We have patented IP and are about to close a fundraise which will provide the required financial resources to scale globally. We have a talented, passionate, and dedicated team to ensure the smooth delivery of our industry-leading technology to market. A partnership with Capital Land will allow us to demonstrate the environmental, sustainability, and operational benefits TrashBot can bring to the organization, and as a first to market with TrashBot in Singapore, reinforce Capital Land's position as a market leader. Thank you.
Thank you, Mr. Fine. And joining him for the Q&A session will be Mr. Charles Yap, CEO and co-founder of CleanRobotics. Your time, your 7 minutes, starts with the first question from Dr. Chong Kun Hian.
Thanks very much, Richard and team. It seems to me TrashBot overcomes many of the human problems of trying to recycle trash. Can you elaborate a little bit on how the robotics work with the AI engine? I suppose it must be some form of a image recognition. So the question really is, how does it recognize trash that is actually not in your database? And how would it sort, and how accurate is it? I think that's the first question. And how many types can you sort it into? Because right now, the proposal is 4 types. I suppose it's also related to the size of the bin. In Japan, they sort a lot more than beyond 4 types. So maybe I'll just stop there and let you answer that question first. Thank you.
Certainly. So it uses artificial intelligence and image recognition to identify the materials. And we obviously have developed a database over time. The more waste that is processed through the machine, the more accurate the machine becomes. And we can classify the waste streams pretty simply. It can classify currently up to 4 streams. We usually find that's enough because generally in most countries they sort up to the 4 streams: metals, plastics, paper, and then organics or landfill. So it can be customized and tailored to sort up to 4 individual streams.
Just a quick addition there. The artificial intelligence can detect 135 different categories of waste, but as far as the bin sorting in the robot itself, it's just 4.
We've got 5 minutes left on the clock. Mr. Rashad is next with a question.
Thanks. Yeah. One of the human challenges is with the sorting, but the other big human challenge, from my understanding of recycling, is contamination. It's one I think that you alluded to on a couple of your pages. And so I'm wondering whether you guys have thought in any way about how to handle that issue, not the sorting, but the contamination issue. And my other question was, what all the potential value streams are associated with the data that you're capturing, not just for this pure recycling solution, but perhaps further upstream, for policymakers or consumer goods companies, et cetera, and whether the extent to which you've thought through some of those value streams as well.
Great question. So regarding contamination, the units utilize artificial intelligence and image recognition to identify the waste. But at the same time, it collects data. So if you find at a specific site you're having a lot of contamination from one of the streams, you can use location-based advertising or messaging on the screen to inform the consumer to change their behavior. So like the example before, it was in the airport, there was a lot of half-filled water bottles entering in that. That's why we display the message, did you know water bottles should be emptied before being disposed of? That's how we deal with contamination issues. The second thing is the value add that you mentioned. We actually see trash robotic having far more value for extended producer responsibility programs in the future. So for example, any take-back scheme, TrashBot could be utilized to actually capture the data of specific brands and account the amount of material that that brand is putting into the system, and therefore make it much more, I guess, efficient and effective across those types of applications.
It's about 3 minutes left on the clock. Time for one or two quick questions. Mr. Lee Chi-kun up next.
Hi, I like the idea a lot. Just a question in terms with regards to implementation. Because if you're going to put in AI and sorting capabilities at each of these different trash bins around the buildings and around the world, how do you, have you tested in terms of the durability, the maintenance? Because if you have a machine that's not durable, and you just do not have the sorting capabilities, and you end up actually creating a lot more problems than what you had originally envisaged. So, yeah.
Yep. Great question. The machines have been developed and refined over the past 5 years. So, and they're built in a very modular way. Anything that goes wrong, there are very few moving parts. Anything that does go wrong with the machine is simply plug and place. But there's very few moving parts, and it's quite a robust, reliable system.
Any other questions from the judges? We have 2 minutes left.
Yeah, can I ask a really quick question? Sorry, I couldn't put it. So let's just pretend I throw an ice cream cone in there. Right? Someone's got to clean it.
So, yeah, the surface of the unit is coated in a hydrophobic coating. So it's sort of, any liquids or contaminants tend to slide off that. But if it did throw an ice cream in, that ice cream would then be separated into an organics or a landfill stream. But the unit itself would require, a regular cleaning as the custodians or maintenance staff come around, or the people that empty the bins, they would just give it a quick wipe down with the cloth.
So it's literally quite as simple as a quick wipe down.
Very much so. Yep, as I say, hydrophobic coating, so it sort of repels any contaminants.
Okay. Thank you.
We've got about 60 seconds. Time for one last quick question and a quick answer. Anything from any judge?
Power consumption. The one thing that regular trash bins have going for them is they don't use any.
Correct. Very low power consumption. At the end of the day, it's driving the monitor, which is an optional. I guess you want that, but as much power as required in order to power the monitor. So very low power consumption.
Well, there you go. There's no time to answer the question if you'll accept bitcoins, but thank you very much indeed for that. CleanRobotics Inc., thank you for sharing with us TrashBot, a smart waste bin which uses artificial intelligence, robotics, and multiple sensors to sort waste to facilitate better recycling efforts.